Uh, okay, so welcome to a short video on skew lines. Skew lines are not just basically there'll be two lines, okay, and those two lines neither intersect nor are parallel. Okay, so those are called as skew lines. Okay, so the idea is I know the kind of problem that we are going to solve next is that let me just show it here. Okay, so say okay, so there are so you can see here actually so there are two lines, okay, um, two lines here, okay, and they are not intersecting. It is very clear, okay, and there is also a shortest distance between them, okay, and we also want to find it. What is the shortest distance? Okay, what should be our strategy, in order to find this? Okay, in order to find that, we note a few things related to skew lines. Okay, so when two skew lines are projected onto a plane, say plane Q, which could be HP, VP, or profile plane, okay, onto a plane, such that the plane is parallel to both the lines. That is important. Don't it's not projecting onto any plane is not useful. Projecting onto a plane that is parallel to both the lines. Okay, uh, so if you project on such a plane, then on that if you find the angle between the projected lines, that angle will be the true angle between the actual lines. Okay, so this is the primary strategy for us. Okay, so we actually have to position the lines, both the lines, parallel to one plane. Okay, all right, and then we are also interested in the distance between the lines. Okay, so what it says is okay, like you projected it to a plane. Let us say call that as plane Q, and of course you could measure the angle between the lines. Now if you find some other plane, okay, let me call that as plane M. The plane M is perpendicular to Q. Okay, just that, no other conditions. There is another plane that is perpendicular to Q, and you also project those lines on that plane M. Okay, so what happens is in M, you would be able to see those two lines as parallel lines. Okay, uh, primarily because of the fact that those two lines are parallel to plane Q. Okay, we will be able to see them as parallel lines, and the distance between the parallel lines is actually the shortest distance between the actual two lines. Okay, so that's the thing, the distance between the parallel projections is the shortest distance between the two lines. Okay, I suggest that you spend a few minutes on this, try to grasp it in your imagination. Okay, all right. So our strategy is to make the two lines parallel to one single plane. So let us get started. Let us see how we can do this. So these are the lines, okay, and they are neither intersecting. They also don't seem to be parallel to any plane. Okay, so how can we check? Uh, Parallel to any plane means not parallel to HP, VP, or profile plane. So how can we check? So for example, if you want to check whether it is parallel to VP, you look at HP, see its inclination with XY line. If they are parallel, then the line is parallel. Otherwise, the line is not parallel. Okay, similarly, you can check in other places also. Okay, so this is front view, this is top view, and this is the profile view. Okay. Uh, uh, okay, so if there's a line, and that if you want to check whether the line is parallel to a particular plane, you have to look at the projection of the same line on other planes, the planes that are perpendicular to yeah, that I mean, let us say I want to check whether this line is parallel to HP. Then I have to check it. I have to look at the planes that are perpendicular to HP. Which are the planes perpendicular to HP? VP is perpendicular to HP, profile plane is perpendicular to HP. I will look at there, and in those planes, if the line appear as a line parallel to XY line, then we can say not always XY line. Okay. For example, if the in the front view, if it is parallel to the XY line, then we can say that the line is actually parallel to HP. Okay. uh, and in the case of profile view, uh, sorry, in the case of yeah, in the case of profile view, okay, if a line is parallel to this line, okay, see, the idea is this, if you take HP, then this line represents VP, and this line represents no, the profile plane. Okay. Now if you look at VP, okay, this line represents HP, and this line represents profile plane. Okay, so if you find that a line is parallel to this line, basically it means that the line is parallel to HP plane. Similarly, if you find that the line is parallel to this particular line, so it actually means that the line is actually parallel to the profile plane. So that's how you sort of conclude. Okay. So anyway, right now none of the lines are parallel to any of the three principal planes. Okay. So, but we want to measure the angle. So, and our the kind of tools that are there for us is just to rotate about the principal axis. Okay, we have not studied about the auxiliary projections, so we are not using it. So our tools is only about rotation. So let me make this line, this red color line, parallel to VP. Okay, and then I will see how I can make the blue line also parallel to VP. Okay, so let me first do it. Okay, so all that I have to do is rotate about an axis that is perpendicular to HP. So when I rotate this, so these points and these points would actually trace circles. Okay, you can rotate about an axis passing through this particular point, passing through point A, let us say. Okay, so then all these points trace circles centered around that axis point. Okay, and here they all trace straight lines. Okay, and the same thing happens here also. Okay, so let us do it. Okay, so I am sort of bringing it to closer to this, and if you carefully observe that, they are actually just moving in straight line, straight horizontal line. Okay, all right, so now it is almost in this parallel to this plane. Okay, so this is HP, this represents the vertical plane, this is the line, and in the HP projection they are parallel. It means the line is parallel to VP. Okay, it looks good. Even in 3D view, it appears that the line is actually parallel to the vertical plane. Okay, now after having done that, what is the next step that we shall take? Okay, uh, so whatever next step we take, should not spoil the parallelism between the red and the vertical plane. So that becomes very tricky, without having to spoil and just making use of rotation about the principal directions. Okay, so what I will do is, in order to facilitate that, I will and one more thing. So when I rotate it, maybe I think I should emphasize this. So earlier the situation was something like this. Okay, so when I actually rotated them, I'm rotating both of them. I'm rotating both the lines. Why is it important? Because I don't want the relative orientation between them to change. Okay. Otherwise, if I rotate different lines differently, so then their relative position and orientation would change, and their relative angle would also change, and that is not our purpose. We want to preserve its original relative inclination, relative orientation, and then measure the relative angle between the two lines. Okay. So that's why, so whenever we are rotating both the lines as if they are part of a rigid body. Okay. So this is the kind of rotation which makes this red line parallel to VP. Okay, so there, I think this would do the job. So you may not be able to see very clearly here whether it is parallel to VP or not, because it's a perspective projection. If you look at the orthographic projection, you see that the line, okay, and this line which actually represents VP on HP plane, they are parallel, so the line is parallel to VP. Okay, and so the next step is, because there is no other way I can make blue also parallel to VP without and also keeping the relative orientation same. So what I will do is I will make this red colored line parallel to HP as well. Currently it is parallel to VP. Next I will make it parallel to HP as well. So this is what I'm going to do. So you look at the front view. The angle with this line. So in front view, this is the line, and this line represents projections of HP. So now I am rotating this line about an axis passing through VP. So this would trace an arc of a circle. Okay, and you see that I am rotating both the lines. Okay, and of course here there'll be just change movement along the horizontal line. Whatever it is, I make it bring it to this position. Now this line has become parallel to HP, and it is also parallel to VP. Okay, so as a consequence, the line will be actually perpendicular to the profile plane. That's why it is appearing as a single dot. Okay, so far so good. Having accomplished this, now what would be my strategy? To make this line parallel to VP. Okay, so one thing that can be done is, now you rotate about an axis that is perpendicular to VP. In fact, you can choose this red colored line itself as the axis. So the advantage is that if you choose that itself as the axis, then because the red line lies on the axis, red line is not altered, okay, as we rotate. Okay, there is no change in its position and orientation. So whatever parallelism it has with HP or VP will be maintained. Okay, so that is the reason why we do this. Okay, so let us say now we start rotating about this particular axis. So uh, the the consequence of the rotation is something you can see. So let me make this line parallel to VP itself. So uh, you know so uh, so if I want to make it parallel to VP, then I have to look at HP. So in HP, this is a line, and this line represents the VP. So this blue line has to be parallel to the 6 line. And similarly in the profile plane, okay. So this is the projection of the line on profile plane, and this represents VP, and this represents HP. We want to make this line parallel to VP, so therefore this should become parallel to this. Okay. So with that intent, I am just rotating about an axis perpendicular to the profile plane. Okay, so as I keep doing it, you see this. Okay, uh, all right. Okay, all right. Now it has become parallel to the vertical plane. So this can be seen both in the profile plane and the HP plane. See, one thing you should always remember: when a set of points you are rotating about an axis, the relative distances, the relative positions and orientation between the points is not going to change. Okay, with respect to HP and VP, it might change, but the relative distances actually do not change. They behave as if they are in a single rigid body. Okay, uh, so here the 4 points, okay, or two endpoints of one line, two endpoints of another line, they're all being treated to be on as a part of single rigid body whenever we do the rotations. Okay, so the relative angles don't change, and the relative shortest distance between them also does not change. Okay, so anyway, I think with these kinds of transformations, we have been able to make them, both of them, parallel to VP. So what I have done is, actually I have formally noted the strategies. What we do: we first rotate perpendicular to uh, you know about an axis, See, I think this is not VP actually. We are rotating what HP to make one of the line, say line AB parallel to VP. Okay, and then subsequently rotate both the lines. So it's very important here, both lines. Okay, I think I might rather put them in bold. Okay, so basically, yeah, okay. So then actually what we did, then we rotate about an axis perpendicular to VP to make the line parallel to, it is not VP as well, parallel to HP as well. Okay, the line AB is now perpendicular to the profile plane. Subsequently rotate both the lines by making axis of rotation to make the axis of rotation, okay, which is also perpendicular to profile plane. uh, okay, to make the other line parallel to VP. Okay, can make it parallel to VP or HP. The choice is yours. Read the angle between the lines in VP and the minimum distance between the lines in HP. Okay, and you can also see it in the profile view, HP and profile plane, PP. Okay, all right. So actually, I'll post this problem to you. I mean, I just want you to solve it. I have given all kinds of solution. I just want you to practice to get the feel of rotating about different axes. Okay. I hope. Okay. If you have any questions, any issues, please do not hesitate to uh, um, contact me. Okay. So with this, I think I'll close this short video. Um,